SurfaceLink uses inertial and acoustic sensing to enable a rich set of natural gestures for multiple devices to communicate with each other on a shared surface. It also combines acoustic stereo positioning with user gestures to accurately infer relative arrangement of devices, thus providing a super lightweight end-to-end multi-device interaction system. SurfaceLink detects devices on the same surface by matching their inertial and acoustic data. Here, the devices match their accelerometer data when a user knocks and infer to be on the same surface. In this case, the two devices, though close to each other, are not on the same surface, so the system flags them with different colors. This capability can be used to develop surface-aware interfaces. Thus, if there is a stationary device on a table, when the user puts their mobile device on the same table, the two devices establish a contextual link. In this case, the device pulls up the relevant slides when kept on a conference table. User knocks are optional, and similar capabilities can be achieved through on-device vibration motors as well. For these device-induced vibrations, we use an inexpensive surface microphone. Here, the device shows the calendar for the day when the user comes to the office in the morning. Similarly, it can also be used to play music when kept next to the speakers. SurfaceLink also provides a rich set of natural gestures to aid in multi-device interaction. It adds directionality to gestures and infers if a swipe is coming towards or going away from the device. In this application, this technique is used to transfer images between the two devices. The user taps on the screen of the device to change the display image and then drags the finger across to the other device to transfer the image. The sending device detects that the finger is going away and the receiver detects that the finger is coming towards it. It can also be used for devices that do not have a touchscreen. Here it is used to send slides to a projector. SurfaceLink also provides multi-finger gestures such as pinch gesture and expand gesture. Here, the pinch gesture is used to establish a mirroring connection between the two devices. Now both devices will mirror each other's screen and the user can change the image on any device and the change will be reflected on both the devices. In contrast, the expand gesture is used to disconnect this mirroring connection, and now both devices are independent of each other. SurfaceLink works well with more than two devices as well, as it robustly disambiguates between participating and non-participating devices. Here we have four devices, and when the user drags the finger from one device to another, the other two devices detect that they are not part of the gesture and do not react. We also detect gesture speed and length. Here, the user draws three different lengths of gesture: full, half, and quarter, and they are all detected robustly. SurfaceLink also detects two different levels of gesture speed. We also implement three different touch modes for our surface gestures: fingertip, fist, and nail. We use the fist gesture for creating subgroup of devices. Here, the user draws a triangle near A, C, and D, hence B is not part of the subgroup. This subgrouping can be used for sharing photos with more than one device at a time. The user simply draws a line from the sending device to the center of the subgroup. Now, user creates a subgroup between A, B, and C, and the images will not be shared with D anymore. SurfaceLink employs acoustic stereo positioning using two inaudible tones for detecting which devices are to the right or left of each other. This capability can be used to create placement-aware interfaces. Here, as the devices know their relative placement, the user can simply send an image to the other device by swiping in its direction. A third device can also be easily added to the setup. This way, any number of devices can be added, but this system works for a one-dimensional arrangement only. In order to infer device arrangement in both the dimensions, SurfaceLink combines acoustic stereo positioning with user gestures. SurfaceLink has the capability to detect different gesture shapes. So, When a user draws a shape with their fist, we compare the time of peak detection on each device to infer their arrangement around the drawn shape. This helps in getting robust estimate of the device arrangement. But in order to disambiguate between mirror images of the actual arrangement, SurfaceLink uses stereo positioning. For example, in this case, SurfaceLink can detect when B and C are interchanged using stereo positioning. Hence, SurfaceLink provides an end-to-end lightweight solution for impromptu and scalable interactions between multiple devices.